morning. So we're going to get started by just doing some practicing with naming since we've already finished the lecture. I'm going to give you guys a bunch of formulas and ask you to name them, and then vice versa. I'll give you a bunch of names and ask you to do the formula. So, unless anyone has specific questions, we'll get started. Sorry, I'm a little tired. I stayed up later than usual. I watched the debate, which was interesting to say the least. Okay. So let's go with formulas to name first. I'm going to just jumble everything all together. So we've got hold on. Okay, so there are 10 here. We have ZnCl2, P3O5, HF, NIN, Al2S3, CO, KNO3, Ti2SO4, LiCl, CrPO4. I want you to go ahead and name all of those. I'll give you 15 minutes to work on those. While you're working on them, if you have any specific questions, you can ask me. Definitely be asking yourself, are they metals, non-metals, predictable, unpredictable charges, so on and so on, okay? So I'll give you guys till like 8:22. Okay. When looking at all of these, the first thing that we're going to want to do is decide, what these things are, as far as the type of compound they are. So this first one here, you've got zinc combined with chlorine. So zinc is a metal. Zinc is also one of the metals that has a predictable charge. Remember, zinc has a 2+, silver has a 1+. So I'm going to name the metal. I don't need a Roman numeral, and then I'm going to put chlor, and I'm going to IDE the end of it, zinc chloride. Next one here, I have to decide what it is. So this is not ionic, it is in fact molecular. It's two nonmetals. So this is where we use prefixes. We don't flip-flop, we don't do anything like that. So in this case, we've got triphosphorus, pentoxide, IDE the end. This thing here, we've got H and F. Anytime you see H in the beginning, you are dealing with an acid. So this is a binary acid. It's hydrogen mixed with just one other thing. So I'm going to go with hydro, base name of the second guy, fluoric acid. Okay, hydro in the front, ic the second guy, and then tag acid on the back. NIN is not an awesome band from the 90s. It is a compound with nickel and nitrogen. Nickel has an unpredictable charge, so I do need a Roman numeral here. I'm going to nitride the end, IDE. Now I need to go back and figure out what the charge is on the nickel. So this whole thing needs to equal 0, correct? We know what the charge is on nitrogen. Nitrogen's charge is always 3-. I only have one of them, so I have a 3- charge for the sum of my negative charges. So my positive charge has to be 3+, or the cation has to bring a 3+. So this is going to be nickel 3 nitride. This thing here, aluminum is a metal, sulfur non-metal. Aluminum has a predictable charge. So this is quite an easy one. I just call it aluminum sulfide. Over here, I've got carbon and oxygen, two nonmetals, so I'm going to use prefixes. I can drop mono on the first one, so this is going to be carbon monoxide. Mono talking about one. Here I've got a metal and a polyatomic ion. If you came to this one and you're like, this is weird, it's not following the rules, there's too many different types of atoms, it's a polyatomic ion. Look at a polyatomic ion sheet. So that's potassium for the first thing. Potassium has a predictable charge, so I don't need a Roman numeral. The second thing is nitrate. I don't change anything about the polyatomic name. I leave it as is. Here, I've got titanium. Titanium has an unpredictable charge, so I do need a Roman numeral. And the second thing is a polyatomic ion called sulfate. Figuring out the charge, sulfate always has a 2- charge. So that means that this has to be a 2+, but remember you've got two of them. So you need to take the charge and divide it by however many are in there. So we would take 2 divided by 2, or this would become titanium 1. This thing down here, LiCl, we've got lithium. Lithium has a predictable charge, so the Roman numeral is unnecessary. And we chloride the second thing. Last one here, I've got a metal, chromium. Chromium has an unpredictable charge, so I need a Roman numeral. And then this glob over here is a polyatomic ion called phosphate. I need to figure out what the charge is. So I know phosphate always has a 3- charge. So in this case, chromium has a 3+, and there's only one of them. So it takes the full extent of the charge. We would get chromium 3 phosphate. Does anybody have any questions on those going in that direction? outside of, just needing to practice them. No, it all makes sense. Easy peasy. It's easy if you can follow the rules, right? If you know the rules, follow the rules. So I would recommend during this next test, since we're in a pandemic and things are a little tough, you get to take the test at home. I would recommend having that flow chart that you have in your text that says, hey, if you have a metal and a non-metal, name it this way. If you have two non-metals, name it this way. If it's an acid, name it this way, so that you just have the rules to help you out. Let's do some going in the other direction. So I'm going to give you the name and I want you to come up with the formula. And each one of you will probably find that you prefer going one direction or the other direction. I'll close y'all out. Okay. Okay, first one we're going to do is calcium carbonate. Then we'll do potassium sulfide. Iron 4. Oxide. Dibromine. Heptafluoride. Silver nitride. Magnesium phosphide. Magnesium phosphate. Copper 1 sulfide. Copper 2 sulfate. Sodium fluoride. Okay, so I'll give you about 10 minutes to do these ones. These ones are a little bit, I think these are a little faster than the other direction. So I'll give you a minute to write them down and then a couple minutes to work. So let's reconvene at 8. We'll just reconvene at 8:45. Okay. If you can't read any of those, let me know. I know my handwriting is atrocious at times. All right, back. So when I kind of find this way easier because I feel like you're given more information, but maybe you won't. And in this case, if I've got a metal and some sort of non-metal or polyatomic ion, I have to balance charges. All right, balance charges. So calcium has a 2+. Carbonate is a polyatomic ion, CO3, with a 2- charge. I'm going to group that together. The charge is talking about the whole packet. Flip-flop, it'll be a 2 and a 2. What happens when we have 2 and 2? We can reduce. So CaCO3, calcium carbonate. Potassium sulfide. Potassium is a metal. It's got a predictable charge. It's not P, it's K. K+. Sulfide, the IDE is talking about sulfur. So sulfur, and it always has a 2- flip-flop. We should end up with K2S. Iron 4 oxide. So iron is a metal. And if you're going, okay, what's its charge? And you start looking at the periodic chart, you're never going to find it. So the charge is given to you here. This is not telling you how many irons you have. It's telling you the charge of this iron. So it's iron 4+. Oxygen is O2-. Flip-flop, we should end up with Fe2O4, which we can reduce down to FeO2. Dibromine heptafluoride. Anytime you see prefixes, you're dealing with a molecular compound, you just pop that as the subscript. So bromine is going to have a di, which is 2. Fluorine is going to have a 7 from hepta. Done. That's it. Done. Silver nitride, IDE, is talking about nitrogen. Silver, Ag, always has a predictable charge of +1. Nitrogen, 3-. Flip-flop, Ag3N. All right, magnesium phosphide. That's talking about magnesium, which has a 2+ charge. Phosphide, IDE, is talking about phosphorus with a 3- charge. Flip-flop, Mg3P with a 2. Now I put this one right underneath this so that you can really get in the habit of looking at the details. So this is magnesium phosphide. This is magnesium phosphate. Those few letters make a huge difference. So magnesium still going to be a 2+ charge. Phosphate, PO4 with a 3- charge. I'm going to sort of packet that. Flip-flop charges for subscripts. So magnesium, I need 3 magnesiums, and I will need 2 phosphates. So PO4, I'm going to put it in parentheses, and then the 2 is going to come around the outside. So Mg3 parentheses PO4 end of parentheses 2. Here we've got copper 1 sulfide. So copper is Cu, and the charge on this is +1 because it's written right here. You didn't have to go find it anywhere. Sulfide is talking about sulfur with a 2-. Flip-flop, I should get Cu2S. Here we've got copper 2 sulfate. So close to this one, but totally different formula. Copper 2 means I'm dealing with Cu with a 2+ charge. And sulfate is a polyatomic ion, SO4, 2-. Flip-flop, they're 2 and 2. I know that they're going to reduce down, so I should end up with CuSO4. I didn't do the intermittent step where I had Cu2, SO4, 2. They both cancel out. Last one here, sodium fluoride. Sodium is Na+, fluorine F-, flip-flop, NaF. And we're done. Okay, any questions on any of those? You've got all of it. You understand it perfectly. Well, that's all I have. If you want to stay around, I can move you guys into breakout rooms and you can do some more work on your lab with some other people in the classroom. And I can come in and help if you have questions. Otherwise, yeah, you're free to go. That's it for the week. So if you're leaving, have a good weekend. And I'll see you next week. Bye, guys. You're staying around, feel free. I can have you do a little extra work.